Hello everybody and welcome to another Advent of Code video, this time for day 7. I had a small break because we had a lot of things to do here in Montreal, but I'm back and I will be trying to catch up with Advent of Code again. So let's get started with day 7. So today's puzzles, or no, not today's, day 7's puzzles are about camel cards. So we will be riding a large camel. And I'll just disable this. We'll be playing a game of camel cards, which is sort of similar to poker, except it's designed to be easier to play while riding a camel. Okay. So in camel cards, you get a list of hands, and our goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled A, K, Q, J, T, and so on. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Every hand is exactly one type. So from strongest to weakest, we have 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair high card. And so hands are primarily ordered based on the type. So 5 of a kind is full house is always better than any of 3 of a kind. It makes sense. If 2 hands are of the same type, the second ordering rule there is comparing the first card in each hand. So we compare the first card in each hand. So basically, we do not care about like the highest card or anything, but first card in the order. If the cards have same label, then we move on second card and so on. So these are both 4 of a kind hands, but this one is stronger, even though A is actually stronger for 4 of a kind. Interesting. That's a odd rule, but okay. To play camel cards, we're given a list of hands and their corresponding bit. That's the puzzle input. So this is kind of a simple input. This example shows 5 hands, each is followed by a bit, and each hand wins the amount equal to its bit multiplied by its rank. Where the weakest hand gets rank of 1 and second weakest gets rank of 2 and so on. So we basically first order them by the strength, which means their rank, which will give us the rank, and then we calculate the final winnings, and the total winnings is by adding up all of that. So seems reasonably simple, but we will need to write the rules properly and not make any major mistakes. So I will start by for this one I will create a hand class which will have a constructor of string cards and bit. So this will store the input basically. And we will also have a method that will give us the how do we call it? Strength or strength is fine. Strength gets strength which will calculate the strength of that hand, and we'll need to put some logic there. So yeah, logic to calculate strength of the hand. We will need to store the ordering of the cards. And do we care actually about yeah, we care about the order of this, so I will copy this, and so I will have a private card or private read-only card ranks. It's gonna be copy of this, just with K, Q, J, T, 9, come on, 8, 7, 6, 5, 4, 3, 2. All right. So if it's earlier on this list, it has a higher value. Okay. All right, because I don't. So this is going to be the card ranks. And I cannot reference it. Right, why cannot reference it? All right, I can actually do this here. Okay. So, and what I will do is I will read the input. So I will lines, read all lines, and for each line we will read that line. So I will take parts, line split, and the line will be the first one, parts. 0 will be the hand, and line parts 1 will be the rank or the bit. So now what we could do is make this a comparable of hand, so that we could compare two hands. And we can do the following. Is null, throw. But now we can if get strength is less than not equal. Also, if it's not equal, then we return, or rather, okay, if get strength compared to other get strength, if it's not equal, then we return, and Otherwise, we return. We will go from the first card to the last one and compare. So we will compare the card rank. So card ranks, and it's so we compare the first one to last. So because we have the card ranks in this order, I need to compare it like this. So index of card ranks, or card ranks other cards E pair to array index of card ranks other cards E. So we compare it in this way, and it's switched up order, and that's because the card ranks are ordered in the descending order of the rank. So we need to order them. The lower one should be going first, so it means that I'm basically switching the order of the result. So this way we should get the right result. So otherwise, like the edge case is that both hands are exactly the same, so then the result doesn't matter. Okay, so we have this. Now we need to calculate the strength of the hand. So what we can do is we can do a dictionary of card counts. It's gonna be this is gonna contain the count of cards of each kind. So I will do it here. So for cards length, I will do card counts cards E plus. So initially it should be 0. So maybe what I can do is initialize it to 0 and then plus plus. So this will increase by 1 initially for each hand and for each card type, and then we get the strength. So we check how do we check for each type? So 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair. So I would do the following. I would rank these by order of magnitude somehow. So 5 of a kind would be, I don't know. So 1, 2, 3, 4, 5, 6, 7. So this would be a 7. So if card counts any is 5, so we have 5 of a kind. Return 7. If card counts any equals 4, we return 6. So 5 of kind, 4 of a kind. So now he has, yeah, this is very good suggestion. So if any card count is 3 and another card count is 2, we have full house. 3 of a kind is the alternative. Then we have 2 pairs. So the number of those cards which have 2 is equal to 2. We have 2 pairs. And finally 1 pair. And high card is return 1. So this is the default, kind of. So that should give us the strength of the card. And what we now do is do our hands equals hand. We add that to the hand, and then we do hands order by. So we try to be by descending or ascending. It's probably ascending, right? So 1, 2, yeah. So order by hands or sort. You can sort by the default compare. So now we have it in the right order, and we have a total winnings equals 0. And what we will do is for hand count, we will do total winnings plus equals hands bit. I will have to expose this as a property, and we take the bit and we multiply it by I plus 1. So that's the rank of the card in the whole pack. And finally we output winnings. So what we can see is, well, let's see what happens if I run this against the sample input. You can see the order when we sort it. So the order should be 3 to T3K, KT, KK, T5, QQ. Let's see. KK. So it seems it's correct. It should be 6,440. And the output is 6,440. So that's promising. Let's see if it's also correct against the big file. Okay, quite a big number. There is a lot of the cards, so we'll see. Oh, it's a correct one. All right, so we are 1 gold star closer. So now let's continue to part 2 of day 7. To make things more interesting, we are introducing one additional rule, and that's jokers. Joker cards act like whatever card would make the hands the strongest type possible. So, but they are also the weakest individual cards. So this one is now considered 4 of a kind because there are 2 jokers. All right. All right, so now we have Joker there. I will put the input again here and take our existing implementation and let's adjust it somehow. So now the rank of J is the lowest one. We have right, so we kind of there was already J, we just switched its value to be the lowest. What we now need is to make sure that the jokers are accounted for in the strength calculation correctly. So J, yeah, joker count, that's good. Joker count, and now we need to make sure so that we use this for the calculation properly. So if there is any card that has value equal to 5 minus joker count, so if there is one joker, we need just 4 of them, it's enough. The same here, minus joker count. Now this one will be more tricky. Yes, we need to make sure that the joker is used. So if we have multiple jokers, all right, that's very confusing here. No, this one is easy. So this is again like this. This one will be more tricky. This one is very easy. So essentially, it's enough. And it's not equal, but greater than or equal. Because it can be that we have just 5 cards. Yeah. Or does it happen? If there's one joker, we need to have 4 other cards. Yeah, it can be just equals, I guess. If there's one joker, it's enough to have a value of 1 for another card. So I guess that it's always gonna be, if there's any joker, it's gonna be at least 1 pair. It cannot be otherwise. The tricky ones are this one, because we can utilize 1 joker. So the options are, we have 1 card, 2 pairs, or 1 joker, 1 pair, and any other card, or 2 jokers. If you have 2 jokers, we always have 2 pairs, because each creates a pair with another card. So yeah, so this one. Okay, so the options are, you have 2 pairs and joker, two pairs of cards, and that's fine. Or we have joker count of 1 and one more, at least one pair, or we have joker count of 2, and that's just it. We just need 2 jokers to create this correct thing. So we have this option. Any better one would be already processed from the previous rounds. Full house will be tricky because there are quite a few options there. How do we do this? Okay. So based on the number of jokers, so we have 0 jokers, the classic full house. If we have 1 joker, it can be we just need, if we have 1 joker, and we would have a 3 of a kind of any card, it would be essentially a 4 of a kind. So that option would be covered here, and we would already have returned. So we don't have 3 of a kind. So it means that this means that we have to have 2 pairs of 2 pairs. So let's do. So either we have this, or joker count equals 1 and card count C two. So we have 2 pairs, or we have 2 jokers. So in that case, if we have 2 jokers, we need to have 1 pair of a card, and then we need just 1 pair of a card, and then we can create 3 of a kind with 2 jokers and that 1 other remaining card. Or we can have 1 card to create the pair, and then 2. So, but if we had 2 cards of the same kind, we would already have had 4 of a kind, because we would have 2 jokers and 2 cards, so it's enough. So I guess this option doesn't matter that much. So I would say if joker count more than 2, we just need a pair. Right, and I forgot one thing. It cannot be joker for these counts. So yeah. So I will exclude the joker from the card counts. And we'll just have a specific property for it. So I will have this. Okay, so if it's a joker, I will increase the joker count, or and otherwise I will just add that number there. So now that makes more sense. So we will have always j as 0, and we have joker count separately. So this is going to be joker count. And now if we need at least one pair of other cards. Okay. Any of a pair. I think this should cover all the bases, unless I'm mistaken. We shall see, I guess. So this is the input. And let's see what happens with... I will also do one thing here and override to string so that we can see the hand right away. And cards. So let's see what happened. Oh, right. I launched the old one. Let's see what happens if I run this one. So 5005. So it seems that this is correct. So let's try again the big one. I hope I didn't miss something. Total winnings. It's a high number, but it could be wrong. And it's correct. All right. I'm pretty satisfied about this one. So yeah, it all worked out in the first try. So that's a very successful day. So I think we're done here. So we have day 7 done, and I will be back for another video with day 8 pretty soon. Plus I will make a AI or ChatGPT versus day 7 video as well. So stay tuned for that. If you want to get notified about new videos, please press the subscribe button, and I will see you in the next videos. Bye bye.